When you think about DIY electronics, two names probably pop into your head: Arduino and ESP32. But listen, this isn't just a battle of technical specs. Nope. This is a story of two titans, born from completely different philosophies and designed to solve completely different problems. Let's see how.
So the best way to really get a grip on these two is to think of them as characters, right? On one side, you've got the Arduino, the great educator. It was literally born to teach, to make tech easy and accessible for everybody. And on the other side, the ESP32, the powerful integrator, a chip engineered from day one to connect our world.
And these personalities, well, they didn't just come out of nowhere. They're baked in right from their origins. So to really understand the hardware, we've got to go back to the philosophies that created them in the first place. What's really wild is that their stories start around the same time, but in totally different worlds. I mean, worlds apart. In 2005, you're in Ivrea, Italy, at a design school, and that's where Arduino was born. The goal? To give artists and students a simple tool for creative expression. Then, just a few years later, flash forward to 2008 in Shanghai, this massive tech hub. Espressif Systems is founded with one single commercial goal: build cheap, powerful wireless chips for the IoT revolution that everyone knew was coming. And this right here, this quote gets to the absolute heart of Arduino. Their whole philosophy was about just enough technology. See, they weren't trying to build the fastest chip on the block, not at all. They were trying to build the most approachable one. They stripped away all the confusing stuff so that anyone, an artist, a designer, a student with zero engineering background, could actually bring their ideas to life. And then you have this, the complete polar opposite. Espressif's philosophy wasn't just enough, it was everything on one chip. Their mission was all about maximum integration, squeezing every last drop of performance out of every dollar. We're talking a powerful processor, Wi-Fi, and Bluetooth, all crammed onto one tiny little piece of silicon. The goal was to power that next wave of smart everything.
So you can probably guess what happens next, right? These two wildly different philosophies led to two radically different pieces of hardware. So let's get down to the silicon itself and see how this all plays out in their core architecture. Okay, so at the very heart of it all is the processor. The classic Arduino Uno, it's running a simple, super reliable 8-bit AVR core. Think of it like an old, dependable pickup truck. It just works. The ESP32, though, that's packing a 32-bit dual-core processor. And look, this isn't just a small upgrade, it's a massive generational leap. It's like going from that trusty pickup truck to a brand new dual-motor electric sports car. So that Arduino Uno's processor, it's chugging along at a steady 16 megahertz. Now, by today's standards, that's not fast, but that's the point. It's perfect for its job, which is just executing one command after another, nice and simple in a predictable loop. And now, look at this. The ESP32 can scream at up to 240 megahertz. That is 15 times faster. But here's the kicker. It's not just about raw speed. That dual-core design means it's a master multitasker. It can handle, say, a complex Wi-Fi connection on one core, while your main program is running totally uninterrupted on the other.
All right, let's talk memory, specifically SRAM, which is kind of like the chip's short-term memory or workspace. The Arduino Uno has just 2 kilobytes. 2. And that, right there, is a huge limitation. It's often the bottleneck that trips people up on bigger projects. It's fine for blinking an LED, but it fills up fast.
And then you have the ESP32 with 520 kilobytes of SRAM. Let me say that again, 520, that's 260 times more memory. And this massive amount of space isn't just for show. It's not just for running bigger programs. It is an absolute necessity to handle all the complicated data that Wi-Fi and Bluetooth stacks demand.
So when you put this spec side by side like this, the difference is just stark. I mean, look at it. From 8-bit to 32-bit, single core to dual core. And the raw performance? We're talking about Elite from around 16 MIPS, that's millions of instructions per second, to up to 600 DMIPS. The ESP32 is just in a whole other league. Oh, and notice that little FPU thing? That's a floating point unit. It means the ESP32 has special hardware just for doing complex math. That's a game changer for stuff like audio processing that would absolutely bring an Arduino to its knees. And all of this brings us to what is, honestly, the single most defining difference between them: connectivity. If you want an Arduino to get online, you have to physically add a separate board, a shield, and they can be kind of clunky and expensive. But for the ESP32,
Connectivity isn't an afterthought. It's not an add-on. It's the whole reason it exists. Wi-Fi and Bluetooth are baked right into its DNA. Okay, so we've established the hardware is fundamentally different. That's clear. So now, let's look at how that design philosophy trickles down and shapes the actual experience of writing code for these two. Anyone who's ever touched an Arduino knows these two words, setup and loop. And this right here is the absolute genius of the Arduino platform. It is such a simple, intuitive model. Your setup code runs one time when you power it on, and then your loop code just runs over and over and over again forever. It is the perfect, gentle on-ramp to programming for the physical world. Now, the ESP32, being way more complex, gives you this cool ladder of options for how you want to develop. You can actually start out programming it just like an Arduino, using the exact same language and IDE. It feels familiar. But as you get more comfortable, you can climb that ladder. You can step up to professional tools like Platform I/O, or go all the way to the top and use the native ESP IDF. That's the framework that gives you total, fine-grained control over the hardware, because you're working directly with its real-time operating system. So that brings up a really interesting question, doesn't it? When you run that super simple Arduino loop on a powerhouse like the ESP32, what's really going on under the hood? Well, underneath that simple facade, there's a powerful, multitasking operating system that's still running, juggling the Wi-Fi, the Bluetooth, and all sorts of other tasks in the background. And this can sometimes lead to what developers call a leaky abstraction, where the simple model doesn't quite hide all the complexity. And this can cause some really confusing bugs for beginners, right? Like, you put a simple delay in your code and suddenly your Wi-Fi disconnects. Why? Because you were unknowingly starving the background OS. Okay, we've covered the philosophy, the hardware, the software, the whole shebang. So that brings us to the most important question of all. Which one should you actually use for your project? Let's break it down and help you choose the right champion.
This chart really makes the choice pretty clear, I think. If you're building your very first electronics project or maybe some kind of interactive art installation, the Arduino Uno is your absolute best friend. Seriously, the barrier to entry is so low and the amount of tutorials and community help out there is just massive. It's the fastest way to get from an idea to a working thing. But the second your project needs to talk to the internet, think a battery-powered Wi-Fi sensor, a smart home gadget, the ESP32 just becomes the obvious no-brainer choice. It's got the Wi-Fi built in, it's got amazing power management, it's just the right tool for any connected job.
So at the end of the day, this isn't about which one is better. It's about which tool is right for the job you have in mind. You have the Arduino, the great educator, the perfect starting point for learning, for creating things that stand on their own. And you have the ESP32, the powerful integrator, the workhorse for building our connected future. You've met them both. The only real question left is, what are you going to build?